Have you ever noticed how your mind seems to shift gears when you're under pressure? That moment when deadlines pile up, unexpected bills arrive, or personal conflicts reach a boiling point, and suddenly your thinking changes. Your body feels different. Your priorities shift. What's fascinating isn't just that we experience stress, but how fundamentally it transforms our brain function in ways most of us never fully understand. I've spent years researching this subject, and what I've discovered about the brain's response to stress has completely changed how I navigate difficult moments in my own life. Today, we're going deeper than the usual "stress is bad for you" conversation. We're exploring what actually happens inside your skull during those moments of pressure, the neurological cascade that unfolds, and how it rewires your thinking in both harmful and, surprisingly, sometimes beneficial ways. By the end of this video, you'll understand the hidden mechanisms at work when you're stressed, including some crucial aspects that conventional wisdom often misses entirely. This isn't about eliminating stress. It's about understanding the profound changes happening in your neural circuitry so you can work with your brain rather than against it. Let's start with what happens almost instantly when your brain perceives a threat or challenge. Within milliseconds, your amygdala, that almond-shaped collection of nuclei deep in your temporal lobe, activates. Think of the amygdala as your brain's dedicated threat detector and emotional processing center. It doesn't distinguish between physical dangers like an approaching predator and psychological threats like a tense email from your boss. To your amygdala, threat is threat. This activation triggers what we commonly call the fight or flight response, though scientists now recognize it includes several other responses like freeze or fawn behaviors. Your hypothalamus receives the amygdala's alarm signal and activates the sympathetic nervous system through the HPA axis, hypothalamic pituitary adrenal axis. It's essentially your body's stress response system. What follows is remarkable. Your adrenal glands, sitting atop your kidneys, release a cocktail of hormones including adrenaline and cortisol. Adrenaline increases your heart rate, elevates your blood pressure, and boosts energy supplies. Cortisol, the primary stress hormone, increases glucose in the bloodstream and enhances your brain's use of glucose. It also dampens non-essential functions during a fight or flight situation. Here's where it gets particularly interesting and what most people don't realize. During acute stress, blood flow in your brain actually changes. Resources are diverted away from regions involved in rational thinking, planning, and impulse control, mainly your prefrontal cortex, and redirected toward more primitive, reactive brain regions. This evolutionary adaptation meant our ancestors could react quickly to predators without getting lost in complex thinking. But in modern life, where most of our stressors are psychological rather than physical, this same mechanism can profoundly undermine our ability to think clearly when we need that capacity most. Have you ever noticed how difficult it becomes to think through complex problems when you're highly stressed? Or how you might snap at someone you care about during a stressful period, saying things you'd never say otherwise? This is your prefrontal cortex going offline while your emotional centers take control. Another fascinating aspect concerns memory. Under moderate stress, the hippocampus, central to memory formation, actually becomes more active, which is why emotionally charged events often form stronger memories. This explains why you might vividly remember details from stressful life events decades later. However, when stress becomes chronic or overwhelming, this same hippocampus can actually atrophy, impairing memory formation and recall. Before I continue with how chronic stress creates lasting changes in brain structure, I want to take a moment to invite you to join this journey of understanding the hidden aspects of how our minds function. If you're finding value in this deeper exploration of how your brain works, please consider subscribing to this channel and hitting the notification bell. Each week, we delve into fascinating aspects of human psychology and neuroscience that can help you better understand yourself and others. Your subscription helps this channel grow and allows us to continue creating content that goes beyond surface-level explanations. Now, let's explore what happens when stress isn't just a momentary experience, but becomes a regular feature of your life. Chronic stress creates a particularly troubling scenario for your brain. When cortisol levels remain elevated over extended periods, actual physical changes begin to occur in your brain's architecture. The prefrontal cortex begins to shrink, a process called dendritic retraction. The dendrites, which are branch-like extensions of nerve cells that help transmit signals from other neurons, literally withdraw and become less complex. Meanwhile, your amygdala, that fear center, actually becomes larger and more reactive. This creates a dangerous cycle where you become more reactive to potential stressors while simultaneously having less cognitive resources to manage them effectively. What's particularly alarming about these changes is that they can persist even after the stressful period ends. Research with both animals and humans shows that prolonged stress exposure creates lasting alterations in brain function and structure. Even more concerning, these effects appear to be cumulative over your lifetime. But not everything about the stress response is negative. In fact, moderate, short-term stress can actually enhance brain function in specific ways. When you experience brief, controllable stress, your brain releases neurochemicals including norepinephrine and dopamine, which can improve attention, enhance memory formation, and even boost cognitive performance. This explains why some people perform better under pressure or why deadlines can sometimes spark creativity. The distinction between harmful and potentially beneficial stress hinges on three factors: intensity, duration, and perceived control. Moderate stress that you believe you can handle and that resolves relatively quickly can strengthen neural pathways and build resilience. It's like exercise for your brain, challenging but ultimately strengthening. Psychologists call this eustress or positive stress, distinguishing it from distress. This brings us to an often overlooked aspect of the stress response: neuroplasticity. Your brain continuously reorganizes itself based on experience, forming new neural connections throughout life. Interestingly, moderate stress can actually promote this adaptability, helping your brain build new pathways that make you more resilient to future stressors. This is why thoughtfully engaging with challenges rather than avoiding them entirely can actually strengthen your brain's stress response system over time. Yet there's an important distinction between facing challenges and drowning in them. When stress becomes overwhelming or unrelenting, those same neuroplastic mechanisms can work against you, reinforcing pathways of anxiety, reactivity, and even depression. Social connection plays a fascinating role in how your brain processes stress. When you feel supported by others, your brain releases oxytocin, sometimes called the love hormone, which actually inhibits the amygdala and dampens the stress response. This tend and defriend response counteracts some of the more damaging aspects of chronic stress and helps explain why social isolation is so detrimental to brain health. Equally important is how stress affects different people differently. Your unique genetics, early life experiences, personality traits, and current circumstances all influence how your brain responds to stressors. Recent research in epigenetics, the study of how your behaviors and environment can cause changes that affect the way your genes work, suggests that early life stress can actually alter gene expression related to stress reactivity throughout life. So what can we do with this knowledge? Understanding the neurological impacts of stress isn't just academically interesting, it provides a framework for more effective stress management. Mindfulness practices, for instance, have been shown to increase gray matter density in the hippocampus while reducing it in the amygdala, essentially reversing some of the structural changes caused by chronic stress. Regular physical exercise increases production of brain-derived neurotrophic factor, BDNF, which promotes neuroplasticity and helps build stress resilience. Even simple breathing exercises directly activate your parasympathetic nervous system, your rest and digest counterpart to the sympathetic, fight or flight system. When you take slow, deep breaths, you're not just calming your thoughts. You're actually sending direct signals to your brain to downregulate stress hormones and restore balance to your nervous system. Perhaps most importantly, recognizing that your thinking becomes fundamentally different under stress allows you to build in safeguards. Many of us make our most important decisions during our most stressful periods, decisions about relationships, careers, or finances. Understanding that your prefrontal cortex is compromised during these times can help you create systems to delay critical choices or seek outside perspective when you're in a stress response. In the end, stress isn't something to eliminate entirely from your life. That would be both impossible and undesirable. Rather, it's about understanding how your brain functions differently under various types of stress and working with these natural mechanisms rather than against them. The goal isn't to avoid stress, but to build a brain that recovers from it efficiently and grows stronger through manageable challenges. I hope this exploration has given you a deeper appreciation for the remarkable adaptability of your brain and how it responds to the pressures of modern life. If you found this information valuable, please take a moment to like this video and subscribe to the channel if you haven't already. Your engagement helps others discover this content too. I'd love to hear about your own experiences with stress and the brain. What techniques have you found most effective for managing your stress response? What questions do you still have about how your brain functions under pressure? Show your thoughts in the comments below. And be sure to check out the description for more resources on building brain resilience and supporting this channel. Until next time, here's to better understanding the magnificent organ between your ears.